2.1, representing relations and functions. Okay. Identify the domain and range of the given relation, then represent the relation using a graph and a mapping diagram. So probably the biggest problem I see with these is that people just don't do all the parts. Okay, so always make sure you read all the instructions and what it wants you to do. So it gives us several sets of ordered pairs, -7, 4, 2, -5, 1, -2, and -3, 6. So, domain are what values? X values. And so we want to write them in number order. Or, well, they don't have to be written in number order. Totally up to you. -7. I'm going to write them in number order because I can. But -3, 1, and 2. And then range values are what? Y values. So we've got, oh goodness, -5, -2, 4, and 6. So that's the domain and range. Then it wants us to represent the relation using a graph. So what's my biggest y value? 6. Now, what you're going to notice is I don't label every little dash, and you don't have to use graph paper. Totally up to you if you want to. But with these, all we do is we plot the points, okay? So people often try to connect them. They don't get connected. They just get graphed. So -7, 4. Uh, 2, -5. 1, -2. And -3, 6. So something like that. And then lastly, we do a mapping diagram. So we have an input column and an output column. So input is going to be our x values, so -7, -3, 1, and 2. Output, -5, -2, 4, and 6. And then we just connect the numbers that go together. Now, the other thing is there were no repeats in either of the columns, but if there is a repeat, we don't write it twice. We only write it once. So -7 to 4, 2 to -5, 1 to -2, and -3 to 6. Now, just curious, is this a function? It doesn't ask for that in this question, but we'll get to that in a second.
Yeah.
Why?
Because it doesn't go to the same output twice.
Yep. So yeah, so each input is used only once, so it would be a function. Do y'all feel like you need to see another one of these worked out, or are we okay like that? Okay. So the next ones, they give you an input-output diagram, and they just ask for you to tell if it's a function or not. So when you do them in your homework, you don't have to like copy the tables over. I'm going to for the sake of examples, but you won't need to do that there. So we have input of -6, -4, -1, 2, and then output 5, 2, 1, -1. And they all just go straight across. And all it wants to know is this a function or not, and why?
Yes.
Why?
Because there's no repeating input.
Yep. Each input is only one output. So it is a function. All right, well, why am I doing that right there? One more of those. Input, output. Input has -1 and 5. Output has 4, 2, -1, -3. So -1 goes to 2 and -1. 5 goes to 4 and -3. So is this a function or not?
Yeah.
Why not?
Because it has repeating input.
Yep. So as soon as you see that there are more outputs than inputs, you automatically know it is not a function. Um, 16 through 19 is basically a combination of this and number 6. So they give you a set or a bunch of ordered pairs, and then they just want you to basically tell if it's a function or not. And so you can use any method. You only have to show one of them to do it. So like with 18, we've got 0, 1, 1, 0, 2, 3, 3, 2, and 4, 4. So which method do you want to use to show if it's a function or not? You can pick your favorite one. It really doesn't matter. Domain and range. Okay. Huh?
I didn't know we actually had to like say something. I thought it was like yours.
So domain and range is going to work the same way as the mapping diagram. If you see that there's more ranges than there are domains, then you know that it's not a function. So domain 0, 1, 2, 3, and 4. Range, we've got, well, I'll just write them down in order as they're written, not number order. So is this going to be a function?
Yes.
Yes, because there are the same amount. So as long as you pick a method to show it, it's good. If you use the mapping diagram, as long as you don't have any numbers that stack on top of each other, or points that stack on top of each other, if you do a vertical line test, which we'll look at again in a second, that also would be sufficient to show that it's a function or not, depending. Okay, so then using the vertical line test, I'm not sure, have y'all seen the vertical line test before? Did you do it in Algebra 1? Okay. So basically they give you a graph and they want you to tell if it's a function or not using the vertical line test. So it looks something like that. So vertical line test, as long as there's only one point at any point that my pencil is going across, it passes the vertical line test and is a function. So this one would be a function.
Wait, so which way do you? I know it's vertical.
This way. Not going to confuse you now, but there will one day be a horizontal line test that you'll learn. All right. Another example, if you had something like that, not a function because it intersects at more than one spot. And if you had, say, a circle, still has spots where it intersects at more than one point, so it is not a function either. Okay, the last problems that we're going to look at say to tell whether the function is linear, then evaluate the function for the given value of x. So for a function to be linear, okay, what has to be true? Like, what form does it need to be in?
Y equals mx plus b.
Okay, that's one option.
Fx equals mx plus b.
Okay, that's the same thing. So you gave me slope-intercept form. That's another option that can be in. To graph a line. There's two other options.
It's a letter.
Well, it's not just a letter, but
I mean, like the first
one starts with an S and one starts with a P.
Yeah.
Or the one that starts with S you may have heard starting with a G before. Standard form or general form. AX plus BY equals C. And then the other one starts with a P.
Wait,
You're close.
What did you say, man?
point form.
It's point something form.
Point.
Point intercept
What do you need to graph a line?
A line.
No, like,
coordinates.
okay. What if coordinates help you find?
Point slope.
Point slope form.
Oh my god.
It's been a long time since we did algebra.
All right, so see, I go over that because every year when we do these problems, people will tell me that a parabola is a line. And I'm like, no, it's not. So f of x is equal to x plus 15. And then they want us to, after we do that, they want us to solve it for the given value. So they want us to solve it for when x is equal to 8. So is this a line?
No. Yes. Maybe. I know you know.
I do know.
Yes.
Okay, what form is it in?
The function notation.
Okay, but what is, let me rephrase. What is this?
Slope plus a point for you graph it.
Well, y equals mx plus b. There's an imaginary 1 here, okay, that is your m, your slope. Okay, you remember that? All right, so this is linear. So then we plug in the point. So f of 8 is equal to 8 plus 15, which is 23. 36. F of x is equal to the absolute value of x plus 10. And then they want us to solve it for f of negative 4. Is this linear?
No.
No. What does an absolute value graph look like? Do you remember?
It's like the y graph. Great.
Can't be a line if you just told me it's not linear.
It's like, I don't know. I know what it looks like. I don't know how to just what it is.
What does it look like?
No.
Yeah.
Looks like this. Absolute value function is a V.
Oh yeah.
So this is not linear. But they do still want us to solve it even when they're not linear. So the absolute value of negative 4 plus 10. So that's going to be 4 plus 10, which is 14. All right, last one, and then we will be done. 38. G of x is equal to x cubed minus 2x squared plus 5x minus 8. And we're going to do it for g of negative 5. Is this linear? We know what kind of function it is. What is this?
Exponent.
Huh?
Not exponent, right?
Well, yes, but like what is it called?
Cubed.
So this is a cubic function. Okay, so a cubic function, just for reference for you, looks something like this. This one won't be exactly like that because it's obviously got other stuff going on, but it's ballpark something like that. So this is not linear. And then plugging in negative 5, so I've got negative 5 cubed minus 2 times negative 5 squared plus 5 times negative 5 minus 8. Negative 5 cubed is?
Negative 25. Wait.
No, it's
Negative 125.
Yeah.
Negative 125. And then negative 5 squared
20.
times negative 2,
Yeah.
negative 50. 5 times negative 5,
Negative 25.
and then minus 8. And so that ends up being negative 208. And then that's it. Cool.
Sure.
All right. I'm giving you a lot of problems today.
I'm probably gonna need it.
5, 11, 17, 21, and 35.
Oh.